Hello, Humans in 5 viewers, and welcome to this week's episode.
Whether it's a show focused on a private investigator, a crime-solving team, a forensic laboratory, or even a serial killer getting away with murder, we love to watch both the science and the law in action on crime television shows. But surely we all know that in the real world, crime solving doesn't happen that way, don't we?
Crime solvers the world over have identified a potential effect of all these crime TV shows, known as the CSI, or Crime Scene Investigation Effect. CSI was a popular television series focusing on forensic scientists using their skills to catch criminals. The CSI effect occurs when members of the jury expect high-tech science from each side of the case. This could be flawless DNA samples, extremely high-quality video images of the crime taking place, or key witnesses. Having seen high-tech pieces of science on TV, members of the jury expect this type of evidence to be brought up in court in real life.
This is particularly difficult when it comes to getting a full DNA readout from a sample of human tissue, like blood or hair. Now on TV, the DNA sample works pretty much every time. The DNA sample also takes the length of an episode to be processed, about 48 minutes, and it is a perfect, high-fidelity result each time. Seeing this on TV, some members of the jury might think that DNA samples can be produced quickly and accurately.
As is often the case with TV shows, they make it out to look much easier than it is in reality. Creating a full DNA readout from human tissue usually takes close to 6 months in forensic laboratories today. So why is there such a huge difference between what we see on TV and what happens in the real world?
For one thing, TV needs to be entertaining. No one wants to watch DNA being processed for one case over a whole season of the TV show. For another thing, like any other business, forensic laboratories have a backlog of cases that do need DNA tests. They also have a limited number of staff and machines. Getting a DNA sample doesn't just happen with one step. There are roughly 9 steps involved in extracting DNA, and each one of these takes at least 24 hours.
First comes screening, where scientists check a tissue sample, like some skin cells or hair, to see if it's appropriate for DNA testing. And not all tissues are. Next is extraction, where bits of DNA are pulled out of the tissues and placed in a test tube.
After that, there's a cleanup phase where the chemicals used to cut out the DNA are removed. Then specialists quantify how much DNA they actually have. Since they rarely have enough, the DNA sample gets amplified. This process mimics how DNA naturally copies itself in your body cells until there are millions of DNA copies available for testing.
The next part is detection. The DNA segments are all jumbled up, so this step organizes them into sequences that can be read and analyzed. On TV, technicians analyze DNA segments by putting them into a machine and boom, out comes the name and address of the perpetrator. But in the real world, unique parts of the DNA segment appear on a graph, which forensic specialists carefully analyze.
Once they've analyzed the result, scientists interpret and report what they found by comparing the DNA segments that have gone through all of this processing to separate DNA samples collected from the victim or from the suspects. Each of these comparative samples also have to go through this whole process.
This is the most time-consuming and complex step because it has to be right. Finally, the last task is to review the tests and results. An external scientist who's not been involved up to this point will review the whole process to check for any potential issues. Since it can be hard to find extra specialists to run these checks, final results can take weeks to be verified.
Whew, well, that was exhausting. So the next time you settle in to watch some TV investigators gather DNA samples, remember the CSI effect and how many steps it really takes to get that key bit of evidence.
Thanks for listening to our case, and we'll see you next time on Humans in 5.
See you then.